Hello guys, so we are starting with 5.2 of the integration chapter. Here we are going to solve examples. So this is called as a method of change of variable or simply method of substitution. So we are going to substitute something in the place of some complex functions, and that is why it is called as a method of substitution. So in here, this is the main formula, that is integration of f of x dx is equal to integration of f of phi t into phi dash of t dt. So this is a bit complex formula, so I'll explain this to you later on. After solving the examples, you'll understand it easily. So it has a corollary. It means the similar type of formulas are simply called as corollary. So the first corollary is uh, integration of f of x raised to n into f dash of x dx is equal to uh, f of x raised to n plus 1 divided by n plus 1 plus c. So you can relate this formula with the simplest first formula we have, that is x raised to n dx. Integration of this is x raised to n plus 1 divided by n plus 1 plus c. So similarly, so what is the relation between these two is, instead of a variable x, if there is a whole function and it has a power n and it's been multiplied with the variable of the function itself, then it can be integrated, the function can be integrated according to this formula, this one. So the formula is similar to this. So when we'll solve some problem, you'll understand it properly. So let's start. Yes, the first problem is evaluate integration of log x raised to 7 divided by x into dx. Now see, I'll first split the given this whole function so that you can understand how we should approach this. So I'll just write it as log x raised to 7 into 1 by x into dx. Now the given corollary that we had was integration of f of x into f dash of x dx is equal to integration f of x raised to n into f dash of x dx is equal to f of x whole n plus 1 divided by n plus 1 and plus c. Okay, so now we can relate this. So this is the function that we have, this is the variable of the function. So for this question, log x is in the place of, yes, log x is in the place of f of x. The n is 7 over here. This f of f dash of s is 1 by x. So you can understand that the function, it has a power 7 and the derivative of the function is multiplied with that. So we can use this formula. So this is how you should approach it. you should do this calculation in your mind so that then you can write the answer properly. So after doing this in mind, you can put log x equal to t, right? Now you can write one more step over here. If log x is equal to t and you derive this with respect to x, so 1 by x will be equal to dt by dx. ठीक है? And then you can write this step. Okay, 1 by x dx is equal to dt, right? So then what we have to do is we have to put t in the place of log x and 1 by x dx you can put as dt over here. So you can see that I have split the given function as log x raised to 7 into 1 by x dx. So in that, so in the place of 1 by x dx you can put dt. So that's how we have got to this. So integration of t raised to 7 dt, the original function has become integration of t raised to 7 dt. So that is equal to, so if we integrate that with respect to t, we are going to get t raised to 7 plus 1 divided by 7 plus 1 with the first formula of ours plus c. Then they have taken this 8 outside and replaced log x with t so that we can get the answer in the original variable. Okay, so that's it for the first example. Let's do the second one. Now the second one is integration of 1 divided by 2x plus x raised to minus n into dx. Now the first thing that we should do in all these problems is to simplify this. So here it is not simplified because x raised to minus n is given, so we have to take a reciprocal of it to make it the power plus. Okay, so that is why this equation, let me zoom in. Okay, so x raised to minus n is equal to 1 divided by x raised to n. So it goes in the denominator and power becomes, power का sign changes. If it would have been plus here, ये minus हो जाता था. ठीक है, so this has become minus plus x raised to minus n becomes 1 by x raised to n. Then they have cross multiplied it. Here there is nothing, it means there is 1. So 2 into, so I think you should write a step over here in the blank space, that is integration 1 divided by 2x into x raised to n plus 1 divided by x raised to n. So this is n. Okay, now see this x into x raised to n is basically x raised to 1 into x raised to n. We know the rules of indices. This x is called as base in rules of indices, and this 1 and n is called as powers. Now if the base is same, we can, and there is multiplication, we have to add the powers. So it becomes x raised to 1 plus n, or you can write the same as x raised to n plus 1, right? So you have to write these steps in the blank spaces so that you can understand it easily when you are revising this. So that's how they have got x raised to n, sorry. So after that step, after that step, what we have got was 1 divided by 2x raised to n plus 1 plus 1 divided by x raised to n. So this is the next step that you have to write in the blank space so that you can understand this step easily. And after this gets reciprocal over here, and then we get this step. So there are two steps in between that they haven't wrote, but you should write it so that you can understand it easily. Next is, so we have got this. Now till this there is no part of integration as such was there. This is just a simplification part. So after this, what I have to do is, so we can see here the right. So you can see the 2x raised to n plus 1 has a derivative. I'll try to take a derivative of this. So if t is equal to x raised to n plus 1, derivative of that with respect to x is n plus 1 in bracket x raised to n plus 1 minus 1. So n plus 1 minus 1. Just a minute. So this 1 and this minus 1 gets cancelled, and what we are going to remain is n plus 1 into x raised to n. So the main thing is that we should understand why we are putting t as x raised to n plus 1 and not this. Is the reason, see in all the corollaries you are going to see that f dash of x into dx is always in the numerator. So you have to find something, some derivatives multiplied with dx in the numerator, and you have to separate the rest so that you can put t to this and you can put dt for this. So that is what your approach should be. So that is why, so we can see that x raised to n plus 1 has a derivative which is closer to x raised to n, and we can adjust it. Let's see how they have adjusted this. So x raised to n plus 1 is equal to t. So derivative of this is as I've just explained, n plus 1 x raised to n into dx is equal to dt. We only have x raised to n dx in the denominator, if you can see. So we have taken n plus 1 on this side. So x raised to n dx, x raised to n dx has become dt by dn. So in the place of x raised to n dx, you have to put this whole thing. In the place of x raised to n, you have to put t, and this is what you have got. Now you can understand here we are integrating this with respect to t, right? So this n plus 1 is constant, so we have to take it outside. Okay, so after taking 1 by n plus 1 common, integration of dt divided by 2t plus 1 remains inside. So this can be solved with the formula in, integration 1 divided by ax plus b dx, which is log of ax plus b divided by a. So similarly they have got log of 2t plus 1 divided by 2. So 2 is the coefficient of this, plus c. So that is what our answer is. Then they have taken this 2 outside to simplify it even more, right? So the next one, now as I've said, you have to check for f dash of x dx somewhere. So this can be a probable f dash of x dx. Then we have to check can we derive any function like this to get here. So can we differentiate a function to get 4x minus 6? And if we cannot do that, we have to adjust some things. Let's see how we have to do it. So you can simply start with this. Okay, so this is x square minus 3x plus 5 is equal to t. If we derive it, so derivative of x square is 2x, and of 3x it is minus 3. So x square minus 3x plus 5 is equal to t. Then 2x minus 3 is equal to dt by dx. So it is basically 2x minus 3 is equal to dt by dx. And then you can write this as a third step. So initially you have to write as detailed as possible. Okay. So after this, we know there is no 2x minus 3 over here. Okay, so that's why they have taken 2 common to get 2x minus 3. Okay, so this 2 we can into this 2x minus 3. So the question itself is formed like that, so that you should be able to predict that you have to take 2 common from here or adjust something else in that. So now 2x minus 3 dx is equal to dt we are going to put in here. Okay, and then put this whole function as t, and this 2 will remain as it is, right? So that is why the function has become, let me zoom in. So I'll explain again. So in the place of x square minus 3x plus 5 they have put t. In the place of 2x minus 3 dx they have put dt, and 2 remained as it is from here. Then what simply we have to do is take this 2 outside because it's a constant, and integrate and then write 2 raised to 3 by 2 as t raised to minus 3 by 2 in the numerator. This you can understand with the relation of powers and indices. So when it is in t raised to 3 by 2, was positive in the denominator, it is going to become negative. Sorry, it's going to become negative in the numerator. And here we can use the formula integration x raised to n dx is equal to x raised to n plus 1 divided by n plus 1 plus c. So instead of x there is t. So we are deriving this here with respect to t. That's why you just have to replace this with t only, and rest the formula is same. So minus 3 by 2 plus 1 is equal to minus 3 plus 2 divided by 2 by taking LCM is equal to minus 1 by 2. So they have replaced n plus 1 as minus 1 by 2 in both these places, and after this 2 gets reciprocal and it becomes 4, and this minus 1 gets multiplied with this 4 to make it minus 4. And in the next step, this t raised to t raised to 1 by 2 is equal to root 2. T raised to minus 1 by 2 is equal to 1 by it is root t. T raised to minus 1 by 2 is equal to 1 divided by root t. ठीक है, as this is because this is equal to 1 divided by t raised to 1 by 2. Okay, it is as simple. Also you should know that t raised to 1 by 3 is equal to cube root of t. Similarly, t raised to minus 1 by 3 is equal to 1 divided by cube root of t. These are called as surds. This root, cube root, these are called as surds. Also fourth root, so these are surds. So you should remember these rules. Okay, in the final step they have replaced t with x square minus 3x plus 5, and then your problem gets completed, right? Let's move on to the next problem. Now you have to look at the problem for a little while so that you can find f dash of x dx. So there is another hint which is not universal, but there is a hint that when there is a power over here, it means it can be f of x, because our formula is f dash of x to the power n into f dash of x into dx. So it means जिस भी फंक्शन को पावर होगा उस फंक्शन वही हमको फंक्शन कंसिडर करना पड़ेगा, और बाकी की चीज़ें, बाकी का f dash of x we are going to get after that. We have to see and adjust it. Now by that logic we can put x plus log x as t. So what we have got is 1 plus 1 by x dx is equal to dt, right, by deriving it with respect to t. Now to adjust, ये 1 plus 1 by x तो यहाँ पे है ही नहीं, so what we have to do, so this they have given. Now I'll try to start again. This you have to put first. This can be your first step, and then you can write these steps. Why I'm telling you? Because after you got to know that this is your f dash of x, then only you'll understand how to adjust it initially. After solving too many problems, you are going to understand it when you see the problem. But when you're solving it, when you're new to this substitution method, you should do you should put t as x plus log x first, and then you should do these steps. Okay, I'll explain again. As f of x raised to n is there in the formula of, that is corollary 1, we are putting x plus log x equal to t here. Then we have derived it with respect to x, so we have got 1 plus 1 by x, where 1 is the derivative of x and log x is derivative of 1 by x, that is into dx is equal to dt. So what we can do, we have to adjust the given function now with respect to t and dt. So we can take this minus 1 by 3 outside. Okay, so this 3 is, there's no minus 1 by 3 but 3 in the denominator. So when you take it outside, it will go in the denominator only. That is why it becomes minus 3. Okay, so then what remains in there is x plus 1 divided by x. Okay, if you separate the bases, it will become x divided by x plus 1 by x. X gets cancelled to make it 1 plus 1 by x. So that is why they have written 1 plus 1 by x over here. Now you can see that this whole is dt, this is t, and we can replace it with t. Okay, so integration, now see, minus 1 by 3 they have put as it is, x plus log x के जगह वो लोग ने लिखा t, and that is raised to 4, and dt they wrote in the place of 1 plus 1 by x dx, right? So after that you have to simply integrate this t raised to 4, it will become t raised to 5 by 5, minus 1 by 3 will remain as it is, plus c is going to add because this is an indefinite integration, and then you have to replace t with x plus log x. That's it. So that's all for the corollary 1 for the solved examples. So I'm going to take the unsolved examples as well, but that I'll take in total. First we'll go through all the corollaries. Thank you.